Okay, so what if the most powerful AI in the world could train its own apprentice, a smaller, pocket-sized version of itself? That's exactly what we're diving into today. This is a pretty wild idea where these massive AI models become mentors, teaching their apprentices not just what to think, but how to think.
So it all kicks off with this number that's, well, it's almost too big to wrap your head around. 671 billion. That's how many parameters, you can think of them as tiny little internal knobs, a top-tier AI uses to reason. And yeah, each one adds to its power, but it also adds to its absolutely colossal size, and you guessed it, its running cost. And that right there, that's the big problem, isn't it? These genius-level models are basically locked away in these massive data centers. They're just incredibly expensive to run and way too big for most of us, or even most companies, to use. So yeah, they're brilliant, but they're completely out of reach.
Which leads us to the big question, right? How do we take all of that incredible brain power and shrink it down? How do we make it small enough, fast enough, and cheap enough to actually run on the devices we use every day?
Well, the solution is actually pretty intuitive when you think about it. It's all about a teacher-student relationship, a way to transfer knowledge from a master to an apprentice.
Okay, so the technical term for this is model distillation. And the idea? It's simple, but it's really powerful. You take a massive expert teacher AI and you use it to train a much smaller student AI. But here's the magic. It's not just about getting the right answers. Nope, it's about teaching that student to copy the teacher's entire thought process.
And this really gets to the core of why this whole distillation thing is so effective. See, instead of just handing the student the final answer, it shows them everything, the teacher's entire thought process from start to finish. You know, it's the difference between just getting an answer key and having a mentor actually walk you through their logic, step by step.
So how does this actually work in practice? Well, the very first step is to craft the perfect lesson plan.
It all begins by giving that huge teacher model thousands and thousands of problems to solve. The teacher then gets to work, grinding through every single one and creating a super detailed step-by-step solution. And this huge collection of expert solutions, that becomes the custom-made textbook for our student AI. So to get really specific, the teacher was handed a set of 12,000 math problems. For every single one, it generated what's called a reasoning trace, which is basically its internal monologue, showing every logical step it took. And here's the part that just blew my mind. The total cost to create this entire library of expert knowledge was only about $50. 50! That is just unbelievably efficient. All right, so the lesson plan is ready to go. Now it's time for the student to actually start learning how to reason like its teacher. The way the student learns is through a method called hard distillation. Now, what that means is its main goal is to predict the exact next word or phrase the teacher would have written. So it's less about some fuzzy, abstract theory and way more about perfectly mimicking the master's language and logic. It's a really direct, hands-on kind of apprenticeship. So this whole learning process is basically one big loop. First, the student tries to solve a problem. Then, its solution gets compared token for token against the teacher's perfect example. After that, the student adjusts its internal wiring to get a little bit closer to the teacher's answer. It's that classic cycle, right? Practice, get feedback, adjust, and repeat. And it does this thousands and thousands of times, getting just a little bit better with every single pass.
Okay, so after all of that training, all those loops, how did our little apprentice actually do? It's report card time. Let's grade the student.
So before any of the training started, our small student model was given a standardized math test, and its accuracy was just 15.2%. Yeah, so that's our baseline. It's a starting point, for sure, but not exactly impressive, is it?
But here's what makes this whole approach so promising. The researchers actually found that for these smaller models, this distillation method can be more effective than other much more complicated training techniques. It's like finding a powerful shortcut to get to high performance.
And honestly, the results here really do speak for themselves. Remember, the students started at a pretty dismal 15% accuracy. But after distillation, its performance absolutely skyrocketed. It ended up right on par with other standard models of a similar size. The apprentice, you could say, has officially learned the master's craft.
So, what does all of this mean for the future of AI? Well, it means we're walking into a brand new era of smaller but much smarter AI. And the shift we're talking about here is it's dramatic. We're going from these huge, expensive, super slow models that are locked away in data centers to small, efficient, and fast models that can run on our own hardware. This completely changes the game in terms of who can access and build with this kind of powerful AI.
I mean, the real-world impact of this is just profound. This technique makes top-of-the-line AI way cheaper to develop and deploy. Pretty soon, the kind of advanced reasoning that currently requires a whole data center could be running right there on your phone. It saves energy, it saves time, and, maybe most importantly, it truly democratizes access to these incredible tools for everyone.
Look, we've seen how well this works for math problems, right? But just stop and imagine the same exact process applied to, medicine, or law, or engineering, or even art. What happens when the greatest expert in any field can train their own pocket-sized digital apprentice for everybody? The possibilities, they're just staggering to think about.